Hey guys, Miss Miklos here, and in today's lecture, we are going to be exploring a brand new set of identities, and these are what we call our double angle identities. And I totally thought that I was on the highlighter there, so let me change that. Okay, there we go. This is what I thought I was doing at that point in time. Double angle identities. So, the way that we're going to go about doing our double angle identities, for those of you that love to derive, you know who I'm talking to here. We're actually going to use our sum and difference formulas to help us figure these out. So we're going to start with sine. So instead of doing sine of alpha plus beta, I have alpha plus alpha, because this would give us 2 alpha, or double an angle. So say it along. We know sine is sine, cosine, cosine, sine. So I'm going to do sine, cosine, cosine, sine. Notice all of my angles this time are alpha because that is alpha in both spots here. And since this is sine, we should have the same operation. So it's going to be sine, cosine plus cosine, sine. Now I want to go ahead and simplify this further. So sine of 2 alpha, I notice that these are actually the same term. Okay, they are like terms, so we can add them together. So I actually have 2 sine cosines there. So our first formula that we need to memorize today is that sine of 2 alpha is equal to 2 sine cosine. And just to clarify, I will never test you guys on deriving these. I think it's just helpful to know where these actually come from. Next one, yep, you've guessed it, we're doing cosine. So we know cosine of alpha plus alpha is cosine, cosine, sine, sine. And we learned that cosine, we do the opposite operation, so it needs to be minus. So if I am simplifying this further, I'm going to say this is cosine of 2 alpha equals, this time these are not like terms. However, I know cosine times cosine, I can write as cosine squared, minus sine times sine would be sine squared. I like how my voice is going out for no reason right now. So I end up getting cosine of 2 alpha is equal to cosine squared minus sine squared. Now, this might look very familiar to a lot of you guys, and we may remember with our Pythagorean identity that sine squared plus cosine squared is equal to 1. So we're kind of adding something new in here, and what we're going to see right now is that there's actually 2 different ways that we can write cosine of double angle. And the reason why this can be helpful is because if I can get this particular equation just in terms of sines or just in terms of cosines, that is less work that I have to actually do when I'm finding those values. So let's say that I want this to just be in terms of cosine squared. So what I'm going to do is I'm going to think, well, how can I write sine in terms of cosine? And I know sine squared is 1 minus cosine squared. Okay, and that's just coming from our Pythagorean identity here. Yes, everything fits together. It's amazing. So what I'm going to do, wherever there was a sine squared, I'm going to replace it with 1 minus cosine squared. So I'm going to write cosine of 2 alpha equals cosine squared minus, and this is where I have my sine squared, so I'm replacing it with 1 minus cosine squared. Now when I distribute this negative, I notice that this actually becomes positive, so I get cosine of 2 alpha equals 2 cosine squared minus 1. So this is the third formula we need to have memorized. So far we have sine of 2 alpha equals 2 sine cosine. We have cosine of 2 alpha is cosine squared minus sine squared. And now we have cosine of 2 alpha equals 2 cosine squared minus 1. Our third and final cosine equation, this time I'm going to write everything just in terms of sine. So I need to think, how could I write cosine squared in terms of sine? Well, using our Pythagorean identity, I can subtract sine squared from both sides, and I get cosine squared as 1 minus sine squared. So in our formula here, I have cosine of 2 alpha equals, instead of cosine squared, I'm going to write 1 minus sine squared, and then I still have that minus sine squared. So I notice this time that my like terms are these negative sine squareds, so I have 1 minus 2 sine squared. So that is our third cosine one that we need to deal with. So far we have our sine of our double angle and we have 3 cosine double angles. Now we're going to end with our tangent double angle. And by end, I mean end with the formulas. Obviously, we still need to learn how to use them. So tangent, we all know tangent was our favorite one to say. I know tan of alpha plus alpha is tan tan, 1 tan tan. I talk faster than I write, so there we go. Tan tan, 1 tan tan. I know I have a same sign in the numerator and an opposite sign in the denominator. So when I simplify this, I get tan of 2 alpha equals 2 tan over 1 minus tan squared. Okay, once again, I already said this, but we definitely do not need to know how to derive them, but sometimes it can be very helpful in figuring them out. So this is what our problems for our homework tonight are going to look like. It says, find sine of the double angle for the angle in the given quadrant. So obviously it's important that we read the directions because regardless of what information comes in the directions, it tells me what I'm actually finding. So this is telling me we're in quadrant 4 and it's giving me a trig function. So I'm going to go ahead and draw this out. I know a triangle in quadrant 4 would look like this. I know sine is opposite over hypotenuse. So I'm going to label the alpha my reference angle, which is closest to the origin. Opposite is going to be -8 and our hypotenuse is 17. Now, in order to figure out this missing leg, I'm going to have to do a squared plus b squared equals c squared. And if I have a squared plus 64 equals 289, I get a squared equals 225. So a is going to be 15. And it would make sense that that would be a positive side since it's moving to the right from the origin. So now that I know all 3 sides of my triangle, I can go ahead and say sine of 2 alpha equals 2 sine cosine. And what we're going to have to do here is we will have to determine what is the sine, what is the cosine, and then multiply these 3 values together. Yes, I said 3 because I'm counting this 2 as one of our values. So I'm going to write this as 2 over 1. I already know that the sine is -8 over 17 because that was given to me in the information. Now the reason why I had to find this adjacent side is because we needed to know the cosine. I know cosine is adjacent over hypotenuse. So our cosine is 15 over 17. Not 7, but 17. And now I'm going to go ahead and I know when I'm multiplying fractions, I multiply straight across. It is always helpful to me when I remember to write a 1 in the denominator there because it reminds me that I am only multiplying the numerator by 2. So when I multiply straight across, I get -16. Let me go ahead. I want to do this correctly. Okay, so I have -16 times 15, which is negative 240. In the denominator, I have 1 times 17, which is 289. This does not reduce any further, so that would be our final answer. Okay, looking at number 2, we have the same exact directions. We're finding sine of the double angle, but this time it gives me tan. So once again, I'm going to start by drawing this out. It tells me it's in quadrant 1. I know alpha is closest to the origin, and tangent is opposite over adjacent. So to find our hypotenuse, I would need to do 3 squared plus 2 radical 10 squared equals c squared. So I get 9 plus 40 equals c squared. 49 is c squared, so 7 is our c value. So now I'm going to have to do sine of 2 alpha equals 2 sine cosine. I want to point out that this is probably the most difficult part of this problem because from there, our math itself is pretty straightforward. So I have, it is equal to 2 over 1. My sine value is opposite over hypotenuse. So I have 2 radical 10 over 7. And cosine is adjacent over hypotenuse, so I have 3 over 7. When I multiply straight across, 2 times 3, we know is going to be 12 times radical 10, so I have 12 radical 10, over 1 times 7 is 49. So 12 radical 10 over 49 is going to be our answer. I promise you guys that using sine of the double angle formula does not get more difficult than this. We just really need to know what that formula is and be able to recall old information that we have previously learned. Okay, example number 3. This time it is telling me to find cosine of the double angle. So it says it's in quadrant 3 and cosine of alpha is negative 3/5. Now, I'm actually going to go through this 3 different ways. And the reason why I'm going to do it 3 different ways is because we have 3 different cosine formulas. And this is the beauty of having those formulas, okay? I know one of them is cosine of the double angle is 2 cosine squared minus 1. The reason why this can be helpful is because I already know the cosine value. I don't need to do any extra work here. So I can just say this is like 2 over 1 times negative 3/5 squared minus 1. So now this just becomes a bunch of math. So I have 2 times 9 over 25 minus 1. So I have 18 over 25 minus, I'm going to write 1 as 25 over 25 because I know I need a common denominator. So when I subtract, I get negative 7 over 25 as my final answer. And the reason why I started doing it this way is to show you guys, if they give us cosine, I think it's easiest just to use the cosine formula because that is less work for me to go ahead and go through. But let's say you just always wanted to use cosine squared minus sine squared. I'm going to go ahead and do that for you right now. Okay, so let's say that I wanted to use cosine of 2 alpha equals cosine squared minus sine squared. So if this was the case, I would need to start by drawing this out. It is in quadrant 3, and I know that alpha is closest to the origin. So I know that cosine is adjacent over hypotenuse, and if I use Pythagorean theorem, I find that my other side has to be 4, and it's going to be negative 4 because it's going down. So if I'm using this formula, cosine is negative 3 over 5, and once again, that was given to me in the beginning. So I'm going to write negative 3 over 5 squared minus, our sine value is opposite over hypotenuse, which is negative 4 over 5 squared. Now, the one really nice thing about using this formula is that we know we will always get the same denominator because the denominator is the hypotenuse in both cases. So I get 9 over 25 minus 16 over 25, which once again is negative 7 over 25, which amazingly is what we got using 2 cosine squared minus 1. So now what I want us to do, we're going to go ahead and go through and actually use the third cosine formula. Okay, now I went ahead and I left up our triangle here. This time I'm doing 1 minus 2 sine squared. So I'm going to say 1 minus 2 over 1 times, we need to figure out what is the sine value. So sine is opposite over hypotenuse. So I have negative 4 over 5. When I do the math here, I get 16 over 25. So this is really 32 over 25. Since I need a common denominator, I'm going to write 1 as 25 over 25. And you guessed it, when I subtract, I get negative 7 over 25. Okay, so I want to stress here, we definitely do not need to use all 3 formulas. You need to have all 3 formulas memorized, but I only need to use one of these to get the correct answer. So I just want to demonstrate how all 3 of them get us to the same exact place. And for our final example in this lecture, we are finding tan of 2 alpha for the angle in the given quadrant. And this time it is sine of alpha equals negative 5 over 13, and it is in quadrant 3. So I need to go ahead and draw this out. So in quadrant 3, here's alpha. Sine is opposite over hypotenuse. So if this is the case, I know that my adjacent side would have to be negative 12. It's negative because it's moving to the left. And I knew it was 12 because this is a Pythagorean triple. Now, if you forgot about that, you could definitely use the Pythagorean theorem and you'll get the right answer. So I know my tan formula is tan of 2 alpha equals 2 tan over 1 minus tan squared. So in this case, I have 2 over 1 times our tangent value is negative 5 over negative 12, which would be 5 over 12 over 1 minus 5 over 12 squared. So when I multiply these together, 2 times 5 is 10, 1 times 12 is 12, over 1 minus 25 over 144. And I'm going to go ahead and take us to a new screen so we can continue to work on this. Okay, so I'm going to rewrite 10 over 12 as 5 over 6. And since I need a common denominator, I'm going to do 144 over 144 minus 25 over 144. So this becomes 5 over 6 over 119 over 144. So I need to go ahead and I'm going to multiply by the reciprocal. So I have 5 over 6 times 144 over 119. And I just put this into my calculator and did math frac, and I got 120 over 119 as my final answer. Now, we have also learned something else about tangent, which applies to tangent of the double angle. We know tan is sine over cosine, so if you ever need to find all 3 of them, if I know sine and I know cosine, I can just divide them by each other and it will give us the tangent ratio. Okay, so hopefully we're seeing that in order to do well on this lesson, first of all, I need to have those formulas memorized. Secondly, I just need to know how to work with fractions.